This lecture is part of an online course of Calculus 1, and I'm going to talk about the situations when the limit does not exist. Okay, so as we said, that the limit of f of x as x approaches the point A is equal to L if f of x approaches to L as x approaches to A. Okay? Now, when x approaches to A, if no such L exists, then we say that the limit does not exist. So let me write a note. I'm going to say that if there is no such L, we say that the limit does not exist. Does not exist. And we usually write this as does not exist. Okay? Let's look at the graph of some situations. So I have one graph, second graph, and let's have the third graph. All of them x, y axis, x, y axis, and x and y axis. Just assume that we have a function that looks like this. We have a function that looks like this, and we have a function that looks like, for example, this. Or actually, let me move this one a little bit up, like this. Okay, so at the point A, okay, you see, if you're getting closer to A from the right, then we get the limit L1. If you're getting closer to A from the left, you see, we are getting the point L2. Look at this one. If this is the point A, and if we are getting closer to A from the right, we are getting closer and closer. F of x actually is getting closer and closer to L1. But if we are approaching to A from the left, as you see, the value of the function would be following this one, which would be L2. Okay? And the last one, like this one, if this is the point A and we are approaching, if x is approaching to A, as you see, the value of the limit or the value of the function would be L1. And if x is approaching to A from the left, then we are getting closer and closer to L2. And the value of the function is not even important, as you see. So in all of these situations, we can say that the limit of f of x for each one of them as x approaches to A does not exist, because we don't have just one L. We have, in every one of these situations, we have two L's. Okay, so that's why we say that the limit here does not exist. Okay, because when we are getting up, when x is approaches to A from the right, we get one number. When x approaches to A from the left, we get another number. So no such unique L exists. So that's why the limit does not exist. Let me give you another example. And the example is asking to find the limit of sine of 1 over x as x approaches to 0. Okay. As I explained in the previous video, we can use a table, we can use a graph, or algebraically we can solve it. We haven't learned algebraic limit laws, so that's why I'm gonna use the table, and then I'm gonna use the graph for it. Let me use the table first. I'm gonna find the value of the function at different points. So the first is using a table, x, and then the function sine of 1 over x. we're approaching to the point 0. So let's put some points that are less than 0, and let's put some points that are greater than 0. So I'm gonna calculate negative 0.1, 0.001, and then negative point, for example, 0.001. Okay, so let's see. For negative 0.1, I get, if I plug in this x into the function, use a calculator, I get 0.54. For this one, I get negative 0.82, and for this one, I'm getting 0.3 and 6, actually 3.1. Okay, let's put some values that are greater than 0. For example, I'm gonna choose 0.1, I'm gonna choose 0.001, and I'm gonna choose 0.0001. Let's see. 0.1, I get negative 0.54. 0.001, I get 83, and if I plug in 0.001, I get negative 0.31. Wait a second, they are very different. I mean, are they approaching to some numbers? So you see, if you're approaching 0, actually let me graph it so that I can explain it better. X, Y, and I'm approaching the point 0 from the left with some negative values, and you see I get 0.5, and then 0.5 in here, and then I get negative 0.5, and then I get 0.3. And if I approach 0 from the right, the same thing, I get a negative number first, and then I get a positive number, and then negative number. What's going on? It's actually isolating, right? So the graph of this function is like this. Let me try to graph it. Oops. I tried actually. So it's between 1 and then negative 1. This is the point 0. Let me show you the better graph so that you can see what's going on. So that's the graph of this function. As you see, it is isolating. So this is negative 2, and then negative 1 somewhere in here, and then let me zoom in so that you see what's going on. Near 0, it's isolating. It's go up and down. You see? It's go up and down near 0. That's why we say that the limit of this function does not exist, because it's isolating. So as a result, the limit of sine of 1 over x as x approaches to 0 does not exist, because it's isolating faster and faster, faster and faster near 0. So these are types of functions that they don't have the limit. These functions that they have a jump, and this function that is isolating. Okay, so now let's look at these 3 graphs. On the first one, that is x squared, the parabola at the point 2, as you see, if you're approaching to the point 2, the value of the function is getting closer and closer to 4. That's why the limit of this function as x approaches to 2, it actually exists, and it's equal to 4. How about the second one? 1 over x. As x approaches to 0 from the right, the value of the function is getting to positive infinity. You see it's getting closer and closer to positive infinity. And when x approaches to 0, the value of the function is negative. It's getting smaller and smaller in the negative side. So when we are approaching to 0 from the right and left, we get two different values. So that's why the limit of this function as x approaches to 0 does not exist, because we don't get a unique number L. How about this one? If x approaches to 1 from the right, we are getting closer and closer to the point 1 actually. That is our value of the function, root x at the point 1. And if x is getting closer to 1 from the left, it has the value negative 1. So from the right we get something else, from the left we get something else. That's why we say that the limit of y as x approaches to the point 1 does not exist. On these situations that the limit does not exist, we have a jump. As you see, from here we have a jump. From here we have a jump. That's why the limit does not exist in these three cases.